So today, think I'm going to be talking about the moons of the gas giants Jupiter and Saturn. Now they have very interesting moons, and I'll start with Jupiter. Jupiter has four moons that I'm going to talk about, and if you know Jupiter's moons, you can probably tell which ones I'm going to talk about. And they're the Galilean moons. Now these are the moons that Galileo Galilei observed in his telescope in 1610, or 1609, 1610, and proved that things don't just orbit around Earth. Things can orbit around other things, and that what led to decline of the geocentric model and heliocentric models. Introduction into scientific uh, world, and eventually was proven to be correct. But the four moons are Io, Europa, Ganymede, and Callisto. Io is the closest one to Jupiter, and because of that, it's tidally locked, which I talked about in a different video. I talked about that one in the moon video and eclipses and such. But basically, to recap, when a larger body and a smaller body orbit each other, over time the larger body makes it so that a day on that smaller body, which is the time it takes for it to just rotate around, is the same as a year, which is time it takes to orbit. So because of that, it's even though it's orbiting, it's still it does from the surface of the larger body. It doesn't seem to be orbiting because it's orbiting as it's rotating. Or sorry, yes, doesn't seem to be rotating because it's orbiting as it's rotating. Sorry, and so you just always see the same side of it. Now Io is tidally locked, which is what that phenomenon is, and because of that, it's being pulled on very extremely by Jupiter. It's being sort of tugged on by its gravity, and because of that, it's extremely volcanically active, and extremely volatile and violent because of that. And it's one of the most seismically active places, basically the most seismically active place in the solar system. And that's obviously incredibly interesting because before that we only knew of one place that was seismically active with earthquakes and volcanoes, and that was Earth. So that was quite a surprise when we found that out. Next, I'm going to be talking about Europa, which is the next biggest. And Europa is incredibly famous because it has water. It has basically what it has is about a 1 to 5 kilometer ice sheet over the top of its surface, and then for miles and miles beneath that, it has liquid water, which, as far as we know, is the one thing life needs, or life as we know it on Earth needs to live. And with water, you could, possibly have life down there. And so the idea is that Europa could have life, and that might be incredibly, incredibly interesting. Next, Callisto. Callisto is sort of the forgotten one because it's not as classy, I guess. But it's heavily cratered, and it has the most craters out of any other object in the solar system. It's the third largest of the Jupiter moons, and of the Galilean moons. Sorry, and I guess Jovian moons too. But it's sort of forgotten about because obviously Io has seismic activity. Europa has water, which is pretty important. And Ganymede is important because Ganymede, although it is a moon of Jupiter, is larger than Mercury and has its own magnetic field that it sustains itself. Now, a magnetic field is basically just when planet's insides sort of are not set; it's churning, and that creates a magnetic field which protects that planet from things like ultraviolet radiation from the sun and ionizing radiation, which is a type of UV rays, but also sort of creates things like auroras on Earth at least, and even Jupiter and Saturn have, since they have a magnetic field, also have auroras on them. There are some beautiful pictures out there of the auroras on Saturn and Jupiter, which I suggest you look up if you haven't. It's beautiful, and if you see some of those close-ups on Jupiter's wind and cloud patterns, it looks like a Van Gogh painting. It's absolutely beautiful. Mwah. But anywho, Saturn has two moons that I would like to talk about. One we've already sort of covered in Europa, Enceladus, because Enceladus also has water, and it has water jets, geysers, which is so basically in the same ballpark of potential life, obviously, which would be groundbreaking because extraterrestrial life would be incredible. But then the other one is Titan. Now Titan is the largest moon of Saturn, and it is incredible because it is surrounded. It has an atmosphere of ammonia, which is well, sort of ammonia. It's a blend, but it has lakes on it, but not of water. It has lakes of liquid methane. Methane is a type of it's just the simplest alcohol, gasoline type of fuel. You probably heard about it before, but yeah. So and it's so cold there that it literally, and we think that it could possibly support life ish, or at least a new type of life because it has a lot of the same qualities Earth did back when Earth back 4 billion years ago when Earth um, spontaneously or however created life, um, and we think it has a lot of the same qualities that Earth did so long ago. So it's interesting to study it because it could give us insights to how Earth worked back then. And that's really all the moons I would like to talk about. Of the gas giants. You can always look up Mimas, which looks like the Death Star, or something else. But not on any other moons. They're all very interesting. But I think that's where I'll end it today. So thank you.